There are moments in history when a single discovery changes everything. When the comfortable lies we tell ourselves about our place in the universe suddenly crack open, and we're forced to look at something we were never prepared to see. This is one of those moments. The James Webb Space Telescope has just confirmed what a handful of researchers have been whispering about for months. The object we've been calling 3I/Atlas, the interstellar visitor that appeared out of nowhere and has been defying every law of physics we thought we understood, is not what we were told. It's bigger, far bigger, and the implications of that size, of what it means for an object that massive to be moving the way it does, emitting the signals it emits, following the trajectory it follows, those implications are keeping scientists awake at night. Because if Webb is right, and the data suggests it is, then we're not looking at a comet. We're not looking at an asteroid. We're looking at something that was built, and whoever built it knows we're here. When 3I/Atlas first appeared in our solar system, the official story was simple. Another interstellar wanderer. A chunk of ice and rock from some distant star system, passing through on its way to nowhere. We'd seen this before. Oumuamua in 2017, Borisov in 2019. Strange objects, yes, but explainable. Anomalies that stretched our models but didn't break them. 3I/Atlas was supposed to be the same. Just another visitor, another cosmic accident. But from the beginning, something felt wrong. The astronomers tracking it noticed details that didn't add up. The way it moved, the gases it released, the perfect alignment of its approach. And now, with Webb's latest data, those details have transformed from curiosities into evidence. Evidence that what we're dealing with isn't a natural object at all. The size revelation came from a routine spectral analysis. Webb's infrared instruments were measuring the thermal signature of 3I/Atlas, trying to determine its composition, its structure, its origin. Standard procedure. But when the data came back, the team analyzing it went silent. Because the object's heat distribution didn't match its visible profile. It was radiating energy like something far larger than what we could see. At first, they thought it was an error. Instruments miscalibrated. Software glitch. But the numbers held. Multiple observations, multiple wavelengths, all pointing to the same conclusion. What we've been seeing, the 46-kilometer diameter object moving through our solar system, is only a fraction of the whole. The actual structure, hidden beneath or around what's visible, could be 3, maybe 4 times that size. Think about what that means. We're not talking about a slightly bigger rock. We're talking about an object potentially 150 to 200 kilometers across. That's not a comet. That's not a fragment. That's a construct, a vessel, a station. Something engineered on a scale that dwarfs anything humanity has ever conceived. And it's been gliding through our solar system, past our planets, within range of our instruments, and we didn't see it. Or more accurately, we saw only what it wanted us to see. The thermal signature revealed something else. Asymmetry. Natural objects, comets and asteroids, radiate heat evenly based on their rotation and sun exposure. But 3I/Atlas shows hotspots, concentrated regions of energy emission that don't correlate with solar heating. These aren't surface features warming in sunlight. These are internal sources, power generation, machinery, systems operating beneath a shell designed to look like rock and ice. And the distribution of these hotspots suggests modularity, sections, chambers, as if the interior is divided into functional zones, each serving a different purpose. When engineers tried to model what could produce this kind of thermal profile, every natural explanation failed. The only scenarios that fit the data involved active systems, reactors, engines, life support. The kind of infrastructure you'd expect from something designed to travel between stars, not over decades, not over centuries, but over millennia. Because to cross the distances between solar systems at the speeds we're measuring, you don't just need propulsion, you need sustainability, systems that can run for thousands of years without resupply, without maintenance, without failure, and the thermal map of 3I/Atlas suggests exactly that. A ship. still operational, still powered, still very much alive. But the size and the heat were only the beginning. Because once Webb confirmed the object was larger than reported, they went back through the archives, every observation, every data point, looking for what they'd missed. And what they found painted a picture so disturbing that most of it remains classified. The chemical analysis, for example. We'd been told 3I/Atlas emits only carbon dioxide. Unusual, yes, but not impossible for a comet under the right conditions. But the full spectral data tells a different story. Yes, CO2 is the dominant emission. But buried in the noise, in the trace compounds most analysts ignored, were other gases: xenon, krypton, noble gases that don't belong in comets, gases used in propulsion systems, in plasma thrusters, in the kind of high-efficiency engines theoretical physicists have been designing for interstellar probes. And then there's the light. We knew 3I/Atlas was bright, too bright for an object of its supposed size and composition. But with the revised measurements, with the understanding that it's far larger than we thought, the brightness makes even less sense. Because larger objects, especially dark, rocky ones, should absorb more light than they reflect. Yet 3I/Atlas glows, not from sunlight, not from reflected radiation, from within. Webb's infrared scans captured it clearly. Photonic emissions, structured light patterns pulsing at regular intervals across multiple wavelengths. The kind of organized emission you'd associate with communication arrays, beacon systems, technology designed to transmit information across vast distances. Scientists ran the light patterns through every analytical framework available: mathematical modeling, signal processing, AI-driven pattern recognition. And what emerged was undeniable: structure, rhythm, sequences that repeat at intervals matching prime numbers, universal constants. The building blocks of a language designed to be understood by any intelligence capable of detecting it. This wasn't random flickering. This wasn't a comet outgassing under solar radiation. This was a broadcast, and it was cycling through phases, as if testing, as if searching for a response, as if waiting to see if anyone was listening. The trajectory analysis became even more troubling with the size revision. Because larger objects are harder to maneuver, they require more energy to adjust course, more force to change velocity. Yet 3I/Atlas has been executing course corrections that would be difficult for a small probe. For something 150 kilometers across to make the same maneuvers, the energy requirements are staggering. We're talking about forces equivalent to multiple nuclear detonations. Yet there's no visible propulsion, no exhaust plume, no radiation signature consistent with conventional thrust. Which means whatever's moving, this thing operates on principles we don't understand. Possibly gravitational manipulation, possibly space-time distortion, technologies that exist only in theoretical papers. Until now, the path itself raised new questions. With the understanding that the object is far larger, its precision becomes even more inexplicable. Because larger objects are harder to control, harder to aim. Yet 3I/Atlas came into our solar system along the exact plane of planetary orbits. It passed within observational range of Earth, Mars, and Jupiter. It adjusted its trajectory at key points to maintain optimal viewing angles. And now, based on projections accounting for its true size, it's heading toward a rendezvous point in the asteroid belt. A location it will reach in precisely 8 months. Not approximately, precisely. As if the entire journey was calculated down to the day. As if someone planned this years ago, decades ago, maybe longer. Military analysts reviewing the revised data came to a consensus that no one wanted to voice publicly. If this object is as large as Webb suggests, if it's moving under intelligent control, if it's emitting structured signals and operating advanced systems, then it's not exploring, it's not observing, it's positioning. For what? No one can say with certainty. But the timing is suspicious. The alignment with Earth's orbit, the approach vector that maximizes visibility from our telescopes, the increasing complexity of the signals as we develop better tools to decode them. It's as if 3I/Atlas is responding to our technological progress, waiting for us to reach a threshold, a level of advancement where contact becomes possible, or where we become worth contacting. Then there's the shadow, one of the strangest details in the Webb data, something that makes no physical sense but appears consistently across multiple observations. 3I/Atlas casts a shadow, not from sunlight. There's no star positioned to create the angle of shade Webb's instruments detected. This shadow originates from the object itself, projected outward, a dark cone extending into space behind the main body. At first, analysts thought it was a gravitational lensing effect, light bending around a massive object. But the math doesn't work. The shadow is too sharp, too stable, too perfectly aligned with the object's trajectory, as if it's being generated deliberately, perhaps as a form of stealth, perhaps as a way to mask something trailing behind, something following at a precise distance, invisible to our instruments, but casting its own gravitational signature, its own distortion in the fabric of space. Researchers began cross-referencing the shadow data with historical observations, and they found matches, faint, easily dismissed. But there, Voyager detected anomalies in the same region of space back in the 1990s. Brief magnetic disturbances, unexplained particle densities. At the time, they were logged as instrumental noise, but reanalyzed now with the context of 3I/Atlas. Those disturbances align. They match the shadow's projected path, as if whatever's creating it has been in our solar system for years, decades, long before we ever detected the main object, long before we thought to look. The biological signal buried in the emissions added another layer of horror. Because when cryptographers finally decoded the mathematical structure of the light pulses, they found something no one expected: patterns that mirror genetic encoding, not human DNA, but similar enough. Helix structures, base pair ratios, the kind of information architecture you'd use to transmit biological blueprints across interstellar distances. Some researchers believe this is proof that 3I/Atlas isn't just a ship. It's a seed, a carrier of life, designed to spread biological information from system to system, perhaps planting it, perhaps harvesting it. Either way, the presence of genetic code in a signal emanating from an artificial object suggests intention, purpose, a mission that involves life itself. The countdown embedded in the transmission has everyone terrified because it's not a human countdown. It's not measured in seconds or hours. It's measured in orbital cycles, planetary alignments, and according to the pattern decoded from the pulses, the countdown reaches 0 in 283 days. Not Earth days, but solar days, measured from the perspective of the object itself, which means the event, whatever it is tied to 3I/Atlas's position, its trajectory, its arrival at the designated point in space. And when that countdown ends, something happens: a signal dispatch, a transformation, a revelation, or something worse. NASA's response to the revised size data was immediate and severe. Observational lockdown, no public releases, no press conferences, telescopes redirected, data streams classified. Within hours of the size confirmation, military satellites were repositioned, defense networks activated. The X-37B launched on an unscheduled mission, and behind closed doors, briefings began. Not for scientists, for generals, for intelligence officials, for people whose job is to assess threats and prepare responses. Because once you understand that 3I/Atlas is a massive, intelligent, operational construct moving through our solar system with apparent purpose, it stops being a scientific curiosity. It becomes a security concern. And concerns of that magnitude require preparation, contingencies, options that no one wants to discuss but everyone knows are on the table. The final piece of the puzzle came from a leaked internal memo. One line, repeated across multiple encrypted channels. Object is not inbound. Object is already here. What does that mean, already here? 3. I/Atlas is millions of kilometers away, still outside the inner solar system, still distant enough that it takes minutes for light to travel from its position to Earth. So how can it be here? Unless the object we're tracking isn't the whole, unless the shadow, the thermal anomalies, the gravitational distortions, unless they're evidence of something else, something that detached, something smaller, faster, already in orbit, already observing, already waiting. Astronomers scanning near-Earth space began finding gaps, blind spots in satellite coverage, regions where data should exist but doesn't, objects that appear for one scan and vanish by the next, unexplained trajectory adjustments in our own satellites, interference patterns that suggest external signals, nothing definitive, nothing provable, but enough. Enough to suggest that 3I/Atlas, the massive construct gliding toward the asteroid belt, isn't alone, that it deployed something, a probe, a scout, a fragment designed to operate independently. And that fragment is here, close, watching us from distances measured in thousands of kilometers instead of millions. Close enough to react, close enough to intervene, close enough to make sure we know we've been seen. So now we're faced with the truth. 3I/Atlas is bigger than we thought, bigger physically, bigger technologically, bigger in implication. And that size changes everything, because this isn't a random visitor. This is a project, a mission, an operation conducted on timescales and distances that defy human comprehension. And we're not observers, we're participants, whether we want to be or not, whether we're ready or not. Because in 8 months, when the countdown reaches 0, when 3I/Atlas arrives at its destination, something will happen. A signal will be sent, a system will activate, a door will open, and whatever comes through that door, whatever emerges from the depths of that massive construct gliding silently through our cosmic neighborhood, it will change us, change humanity. Change the fundamental nature of what we thought we knew about our place in the universe. The James Webb Space Telescope confirmed the size, but it also confirmed the fear, the growing undeniable understanding that we are not the apex of intelligence. We are not the masters of space. We are not alone. And the thing that's out there, the thing that's been watching, waiting, approaching with calculated precision, is so much larger, so much more advanced, so much more terrifyingly deliberate than we ever imagined. The question now isn't whether contact is coming. The question is whether we'll survive it.